Hey class, welcome to another edition of our virtual math class. But the good news is this will hopefully be our last one. I am so sorry I'm still not back in person with you, but I hope to be back so soon. So we're going to do one more video lesson. You guys have been doing so great. Now before we begin, a few reminders just to make sure we're all on the same page. First, please watch the entire video using headphones. I will be checking that you've completed all of the notes when I am back. Make sure you are copying everything you see me write down because it is all important. You will get homework assigned and it will be due next class. I will be collecting all of the homework that has been assigned so far, so make sure you have all of it ready. And lastly, of course, email me with any questions at all. I can be reached at agoldberg@oapb.org. Let's get started. Go ahead and put your notes in front of you. They should look like this. We are talking about section 1.6, relations. Now, in math, relations are not who is dating whom. It is more about the relationships between numbers and how they work together as part of a group or a set of data. Now, before we get into the meat and potatoes of it, let's review some things we've learned in the past. We are going to be talking about coordinate systems today. Now, a coordinate system is like a map for math. It is where we use a grid that looks like this, that has been formed by the intersection of two number lines. The horizontal axis, which is the x-axis, and the vertical axis, which is the y-axis. So the x-axis is always the line that goes straight across. See how it's labeled here, x? That is my x-axis. The y-axis always goes up and down vertically. That is labeled y. That is important to make sure we are putting our points in the right places. If, let's say, I decide I want this to be x and this to be y, but Tommy decides he wants this to be x and this to be y, we're going to have different information on our graphs, but we're trying to represent the same thing. So we all have to follow the same rules. That's why they decided x is always horizontal, y is always vertical. So that vertical axis, that vertical line, we call it the y-axis. The horizontal axis is the x-axis. Now, this whole thing with both axes combined to make the intersection and the grid beneath it, we call that the coordinate plane. That's where we are representing our data or showing our numbers. Each point on the coordinate plane is called an ordered pair. So we can see one of those right here. Now, an ordered pair is a point on the graph, and it's represented in the form of x, comma, y. It will always be two numbers. The first number is always the x value. The second number is always the y value. We use those numbers to tell us where to go on the graph. So see how this is 2, 3? That means we start here and we go to the right 2 places and then up 3 places. 2 places on the x-axis, that's why 2 is in the x spot, and 3 places up on the y-axis, that's why 3 is in the y spot. Now, how do I know whether I'm starting here or maybe I'm starting down here and going over 2 up 3? Well, we always start at a special point called the origin. The origin is the intersection or the point right in between the two lines, and it is always 0.0, 0. That's like our starting point. That's like in a board game, the green square that you start on is the origin. You always start in the same spot. Now, a point on a graph that we have represented as x, y can be represented using ordered pairs. An ordered pair is a set of numbers written in the form x, y. The x value is called the x-coordinate, and it represents the horizontal placement of the point. So the number in the x position, the first number in the parentheses, is how far left or right you're going to go. Then the y value, or the y-coordinate, represents the vertical placement, so how far up or down you're going to go. A set of ordered pairs, so a group of ordered pairs all on the same graph, is what we call a relation. It's showing how they are all related to each other in this space. Are they close to each other? Are they far away? Are they on the same line? What is the relation? A relation can be represented in several ways. We can show it as an equation, in a graph, with a table, or through something called mapping that I'm going to show you in a minute. Now, a blank illustrates how each element is paired with an element in the range. So a mapping is what represents that. And a mapping shows me each point of the domain, which is the x values, and how they are paired with a point in the range, the y values. The set of the first numbers of the ordered pair is what we call the domain. So when I say, what is the domain of this relation? You're going to tell me all of the first numbers in the ordered pair, all of the x values. The set of second numbers of the ordered pairs is the range. Those are all of your y values. So here are examples of the 4 ways we can represent those x and y values, those relations. The first is in ordered pairs, where we just write it in the form x comma y. So you have 1, 2, 3 ordered pairs in our relation, representing your x's and y's. Remember, x is domain, y is range. The next way we can represent our data is with a table. Now in a table, you're taking the same data, the x's and y's, and you're just splitting them into separate columns. The x's first, and then the y's. So you can easily see, well, here's my domain, 1, -2, 0. And here's my range, 2, 4, -3. Now, a graph is a great way to see all of our data that is in a relation. So here we can see the points of the graph. The first one is -2, 4. They went up to the left 2, -2, and then up +4. So that's the first piece or point in our relation. Then we have 1, 2 over 1 up 2, and 0, -3. Now 0 means we're not going left or right on the x-axis. So we just we stay on the y-axis and then go down 1, 2, 3. Now the last way we represent our data is with mapping. And mapping is where we show the domain on the left, the range on the right, and the arrows represent the relationship between the two. Now, for mapping, we list each number only once. That's going to be important on the next page. So that's the difference with mapping. You're only going to list each number once, even if it shows up more than once. Okay? All right, moving on. Now, let's practice this with our relation that they've given us. Here's the relation. Notice how it is a set of points. And remember, those points are in the form x, y. So the first way to represent that is in a table. So we're going to take all of the x values. Those are the first numbers. And then the y values are the second numbers. So first one is 2, 5. Then -2, 3, 4, -2, and -1, -2. So that's how I put my relation into the form of a table. Next is the graph. So remember, we always start with the x, and that's how far left or right we go, and then we count out the y. That's how far up or down, depending on if it's positive or negative. So if the first point is 2, 5, we always start at the origin. We go to the right because it's positive. To the right 2, and then up 5. 1, 2, 3, 4, 5. And then we label it 2, 5. Next up, we have -2, 3. So we go back to the origin. -2 means we go to the left. 1, 2, negative. And then +3 means we go up 1, 2, 3. So this would be -2, 3. Next, we have 4, -2. So we're going to go to the right 4. 1, 2, 3, 4. And -2 means we're going down 1, 2. So this would be 4, -2. And the last point is -1, -2. So I start at the origin. -1 means I go to the left 1. -2 means I go down 2. So I put my point right here, and I label it -1, -2. Now, my last method of representing my data is with mapping. So remember, for mapping, the domain goes first. That's your x values, and then your range. Now, we don't want to repeat any numbers. So first, I'm going to look at my domain. My domain is 2, -2, 4, and -1. Now, my range are the y values. So that would be 5, 3, -2, and -2 again. Now, for mapping, and only mapping, we don't want to repeat any range values. So because we already have -2 here, we're just going to leave it and not write it again. It's already there. We're going to represent that it's used in a second set of data with those arrows that we talked about. So the arrows connect the points that go together. So the first one is 2, 5. So the arrow connects 2 and 5. Next was -2, 3. So -2 and 3. 4, -2. And then -1, -2. Now notice how we have two x values that have the same y value. That's going to be important in a minute. Moving on though, let's list out now the domain and range of the information above. So we've already shown it with mapping, graph, and table. So we're just going to now write it out. Domain, those were all of our x values. So 2, -2, 4, and -1. The range are the y values, so that's going to be 5, 3, -2, and -2. Now, moving on, let's talk about our variables. Independent variables. The value of the variable, if it's independent, that determines the output. It is also known as the input or domain. So independent variables represent the domain. The domain represents the independent variables. That means they are the x values. So the x values are independent. They determine what the output, what the answer is going to be. Now, dependent variables, the value of the output that is reliant on the input. This is also known as the, take a guess, range. So that means it is the y values. So independent is domain, dependent is range, meaning the y value is going to change depending on what the x value is. Y values are dependent, x values are independent. So, in our first example, identify the independent and dependent variables for each relation. So, the first example is the air pressure inside a tire increases with the temperature. So, what is dependent and independent? Well, independent variables determine the result, determine the outcome. And what is determining the air pressure? The temperature. So here, the temperature is going to be independent. We can't control the temperature outside. We have no control over it. There's no giant AC we can turn up. So the temperature is independent, meaning it determines the output. So the dependent that is determined by the temperature would be the air pressure in the tire. That air pressure is going to change depending on the temperature outside. This is a true fact. The hotter or colder it is outside depends on how inflated your tire is inside the tire. So temperature is independent, and then it determines the dependent variable, which is air pressure. So try number 3 on your own. As the amount of rain decreases, so does the water level of the river. What is the dependent variable and what is the independent variable? Well, as the amount of rain decreases, so does the water level of the river. So what is changing? The amount of rain. That is going to determine the water level of the river. The water level of the river does not determine how much rain falls. It's not like the weather, Mother Nature looks down and is like, oh, that river is pretty full, so I'm not going to rain today. It doesn't work that way. So the amount of rain would be the independent variable. We can't control it. But it will determine the water level of the river, meaning the water level is dependent on the amount of rain that falls. More rain that falls equals a higher water level. All right. Now, the last page, we're going to talk about how to kind of read and represent data with a graph. So a relation can be graphed without a scale on either axis. So these are just our general graphs. They're kind of generic, meaning there's no measurements. See how it just says time? It doesn't say it's minutes, hours, seconds, etc. These graphs can be interpreted by analyzing their shapes. So that's what we're going to be doing, analyzing the shapes of our graphs. So take a look at the first graph and just take a second to read what it's about. You're always going to read the title first and then the 2 descriptive axes. and think about what is it showing. I'm going to give you 30 seconds just to think about that one. Now, the title tells us we're talking about a bike ride. The y-axis represents the distance that is being ridden, that we are riding. And the x-axis represents how much time we are riding our bike. Notice how the x-axis, the time, is continuing to increase. We're moving further to the right. Time, we haven't learned how to time travel yet. We can't go backwards with time. So time is going to increase no matter what. We can't control that. We can't change that. That's why time is always going to be on the x-axis. It is always going to be the independent variable. So time will always be independent. We cannot control it. But what we can control is the distance we're riding in that amount of time. So now look at the graph. First, it shows that as we're moving along the time axis, first our distance is increasing. Then it stays the same for a while. The time continues to increase, but the distance is no longer increasing or going up. And then we finally start to climb with our distance again. So what do you think that means? Well, the best way we could describe what has happened is we could say, well, we start on a bike ride, we ride for a little bit, and then we take a break. So time continues to pass. We don't press pause on the clock, but we're just sitting there. We're just chilling, drinking our juice. So we would describe this as time increases, distance increases, but only at first. Then we take a break, so distance stays the same. After the break, we continue riding again. Ooh, should be a D. Riding again. So distance, well, as we ride, distance increases. So distance increases again. That's why we have this plateau here. So let's do the same thing for the next one. This time they don't give us a title, but they are telling us that we're measuring time. That's always the x-axis. And sales. So we're showing how sales change over time. So first sales increase, then they fall, then they increase again, then they stay the same for a little bit, and then they finally continue to increase at the end. So that's how we're going to describe it. When you're describing your graphs, be as specific as possible to everything you see in the graph. So we're going to say, as time increases, sales first climb or increase, then they fall, then they increase again. So here they increase, then they fall. Now we're increasing again right here before staying the same for a while. Finally, sales begin to increase again. All right, that's the kind of answer I will be looking for on your tests. Now, the last part, we're going to actually draw the graphs and not just interpret them. So first, an athlete alternates between running and walking during a workout. All right, so we're going to represent this graph first with a graph. So let's draw our little graph, X and Y axis. And so we're talking about an athlete, and he's alternating between running and walking. So running and walking, these are speeds that he is traveling at. So that means that we could measure the x-axis as time and the y-axis as speed. So as time begins, well, he's doesn't just wake up running, so he starts at a standstill. And then he increases his speed and he runs for a while before he walks. He slows down and walks for a while. Then he speeds up and runs for a while. Then he slows down and walks for a while. So that's what our graph would look somewhat like. An increase as he speeds up, and then he runs, and then he slows down and walks, speeds up and runs, slows down and walks. And the last one, a grandfather clock that is over 100 years old has increased in value from when it was first purchased. So, start with our graph. We're going to label the x-axis as time, and we are talking about the value of the clock. It's over 100 years old, and it has increased in value from when it was first purchased. So as time has continued, the value has increased. So time continues, the value increases. All right, so those are our notes for today. You will have homework that has been assigned. It is on Veracross. It is pages 43 through 45 and these selected questions. So please go ahead, review your notes if you need to, and then get started on that homework. I will be checking it next class. Thanks so much, guys. Have a wonderful day.